Lesson 13.5, writing right Riemann sums as a summation guided. It says, let f be the function graph below. If 20 subintervals of equal length are used, write a summation that would represent a right Riemann sum approximation from 0 to 2 of f of x dx. So a couple things I want you to notice is, for one, we know we're going from x values of 0 to 2, and they do give you this graph, so that helps. We also don't have a specific function still. We just have f of x, which is just a generic function. What I would do first is figure out how wide my rectangles are. So if I'm going to have, and this is called your A and this is your B, you subtract B minus A, so it'd be 2 minus 0 is a width of 2 divided by 20 subintervals would be a tenth. That number, that is your width every time of every rectangle. You'll also see, if you ever look at how they explain it on Delta Math, they'll call it delta x. That means change in x. That's what x is changing by. And so that's going to go in the second parentheses. Because all we're doing is basically saying, I want to find the area of all my rectangles summed together. We learned this is the letter that really is a capital S, summing together all these rectangles from 0 to 2, and I know they have a width of 1/10. So width goes here. Now I need a height here. That's a little harder because, for one, I've got to figure out how this is happening. What does this mean? Because I'm going from 0 to 2. Well, now I'm using K's. K's are my rectangles. Like, this is the first rectangle. So this would be K sub 1. K sub 2, K sub 3, all the way to K sub 20, because it told me there was going to be 20 rectangles. So that's how many rectangles total go up top. Okay, so in here, the height. I know it's the y values, but how I want to find that then is think about each height. This first one starts at an x value of 0. And then it adds, I know this width is a tenth. And so then it would be finding y of that value, f of a tenth. The next rectangle over would be starting at 0, but I'm adding 2 rectangle widths, which is 2/10, and finding the y value of that. So I wanted to find this height at 2/10. The next one would be of 3/10, of 4/10. So each time the numerator is changing because I'm getting more and more 1/10. Well, I need to say, okay, my number is changing by k. The first rectangle, this is when k is 1, or the first rectangle is 1/10. My second rectangle, or k sub 2, would be 2/10. K sub 3 would be 3/10. So the way I could write a pattern for any of these rectangles is call it, or say it's 1/10 times k, which I can multiply the numerators and say that's k tenths. So I would want to have that go in for x. So it'd be f of k over 10. And that's it. You could put 0 plus k over 10, since technically we're starting at 0. You'll see on the other example, sometimes they don't start at 0. You would have to have that number plus your fraction. And then what I want to show you is down here. I just thought this was a good visual. So we said there's 20 rectangles, and that represents your k values. This is how to find the area of the first rectangle. We said it's starting at 0 on the x-axis, adding a tenth for the width, finding the height, or the f of that value, and then times the width of a tenth. So height times width, and then they're estimating what it is. So a tenth times a tenth, blah, blah, blah. They're telling you that it's that and that and that. So then they're saying all the way to here. They didn't give me a summation, maybe I cut that off. But that kind of helps me see that, okay, k is changing every time, and this k will match that. So it helps me find the pattern. Okay, one more of these. And this time we still have 20 subintervals. So I could go ahead and put that I'm going to have 20 rectangles of equal length, and then we're still doing a right Riemann sum. There'll always be a right, just so you know. And then we're going from 2 to 6. So let's take our b minus a, our 6 minus 2. We're covering a span of 4 units on the x-axis, divided by 20 would be a fifth. So that is my width of each rectangle. Each little one is 1/5, 2/5, 3/5, 4/5, 5/5, all the way to get to a whole number of 20, which would be 100/5. Okay, and then I've got to find my height. So this is width. Find my height here. This time I'm not starting at 0, I'm starting at 2. So the way to find your height is saying it's your a value, what you're starting at, plus your change in x times k. But I just find this confusing. I'd rather use common sense about it because it's getting so many variables. My mind just doesn't really wrap around it. Now the more I do it, it is, but in the beginning I remember it being super hard. So really our change in x is the 1/5. But what I'm saying is this first rectangle, so k sub 1, would be starting at 2, adding a fifth, and that would get me at 2 1/5. I want to find the y value of that, so it'd be f of that. Then I could say k sub 2, my second rectangle, would still be starting at 2, but then adding 2 1/5, 2/5. K sub 3 would be finding the height at 2 plus 3/5. So I'm getting further and further away from 2. So then I can say, well, this is just k changing. So I would say it's my 2 plus my change in x, which is a fifth, times k, because I'm having that many k, that many rectangles of a fifth. So it'd be 2 plus k fifths. And it's f of that x value. So 2 plus k over 5, and then when you submit the answer, you'll see this right here. It's exactly what we were doing. That here's the first rectangle, k sub 1, 2 1/5 times a fifth. That'll give you all the totals. See here, I do see the total. So it's telling you the Riemann sum, that the area of all the rectangles under that curve is 72.56 approximately.